Good night, and tonight we're going to configure this TBB. Now after mounting this hybrid off-grid, so we're going to power this up. uh, so as my previous videos, I've discussed some functionalities. But in this case, I've already rewired it. So I'm using a 6 AWG. So that's 25 mm thickness. And as you can see, I'm only wired the AC1. This is the AC1. This is the AC in. Yeah, and this is the AC out 2. So based on the manual, AC out will only be present if there's a grid. So if there's no grid, automatically the output 2 will be disconnected. So the Energier manufacturer is giving you a versatility when it comes to designing your system. So again, it's a system approach on how do you capitalize on this thing. But if I were to use this one, I'm going to connect my motorized loads in here, so that when no grid will happen, this will disconnect, so only the essentials or necessary loads can be powered up. So on the other side, we can see that there's I'm going to remove this. This is the RS485. If you could see it properly, let me see. I'm going to, okay. So that's the RS485 or the CAN bus if you have the battery. So I'll be using this battery, lithium. Based on its specs, it's 54.6. So it's a 3.7 lithium battery, prismatic. So I'm going to use this. This is a 120. So let's power it up just for the purposes of demo. And because I'm also going to have a YouTube on this, unboxing and stuff. So just to have a idea, so our battery is 120 ampere hour. So currently is 78% states of charge. So it communicates through CAN bus. So I have the RG45 and also the RG45 in here. So it has 4. And other stuffs are, you have the auxiliary connections. Now this one is very interesting because Energier, you will be able to I would say program its dry contacts. They call it dry contacts because it's a relay. So dry contacts are relays. It's just a matter of on and off. So you can use a PC, which PC application which is not yet available. The distributor says it's next year, or you can use it through your LCD. So it's currently off. And the other one is this one. I've connected the battery sampler. Now it's important to connect the battery sampler to your battery to be able to get the exact battery voltage. So it has a calculations on during, because you're charge and discharging, so the inverter should be able to get what's the exact battery voltage that you have. That's why it's a separate connection, and you need to I would say it's a must. On the left side, this one with the loop, this is what they call EPO. Oh, it's emergency power off. This is good if you're having problems with your inverter, so you can just wire this outside and make it as an emergency stop. So automatically your hardware will shut down, which is good. And on the video, on the unboxing, I've said that this one is power mode, but it's not. This one is really an on and off. So the rocker switch is really to control your TBB to shut down, to turn it off properly. Okay, so there's a lot of functionalities involved. I might do a exclusive video on how do you capitalize it, and we can also see that on the LCD. But for now, we're going to configure this properly. So how do you configure properly a hybrid off-grid? My other videos is how to configure a hybrid on-grid. Now this one is a different. If you are configuring a hybrid off-grid, you start with the battery first. You don't start with the AC or with the grid in. It should be off. So this one, both AC out and AC input is off. So there's a reason for that. And we're going to configure this using the battery mode, not on the grid mode. I'm going to explain it later. Okay, so I'm going to mount this and we're going to start. So let's turn the inverter on. So we all know that it has a huge fan at the bottom. So the current battery is 51.2. So it's running. So we'll just wait. Like any machines, it goes to a POST checking. Your computer does, and inverters is no different because it's also run by a computer. Okay. Like I always recommend that when you're doing a configuration, you need to first reset, regardless of the if it's brand new or it's being second-hand. Always reset whatever on the inverter for safety. So to reset this inverter, so let's go to control, enter. So the password is 123. Just enter and enter again. So it asks for equalization. We don't do that because when you say you're going to equalize your battery and it's a lithium battery, you don't equalize a lithium battery. Factory reset, that's what we need. Okay, so accept. So it's a success. So AC input under voltage, it's because this one is turned off, so there's no AC in, and also there's no AC out, so that's okay. So let's go to settings. We're going to set this thing. So password, same, general, enter. So our battery is a lithium battery, so we need to change the AGM. So gel, it has a lot of settings, or a battery type which integrated in this box. So attraction, most cases these are tubular batteries, lead carbon, and LiFo. So we're going to choose this. Okay. Next, capacity. So we're going to enter the capacity. Since we know that it's 120 Ah. Okay, success. And next would be, is this a power backup or a pure inverter? That means to say this one's power backup will act as a UPS. So there's only two modes on this thing, a UPS and wait, oops, sorry. So there's only two modes, UPS or solar mode. So some call this is a solar backup, solar battery and utility mode. And but this one in this case, it's called solar mode. So that's to say solar priority. So we choose this. Okay. So I'm using the SBU side, means say the solar battery utility, for this testing and for this setup, because I want to test also my battery. So that's why I'm going to bypass everything on my load. All will be handled by the Apollo Energier. Next, AC source standard. So that means to say my grid is stable, because there's a lot of options in here. You can have a weak grid, a generator type of supply, weak generator type, or standard. But since my grid in my place is stable, we use the standard. Next is AC input current limit. So we'll leave it that way. That means to say it can, on most cases, if you want to do bypass, or if by the time that the load will hit, I would say the AC input current limit is when the server goes, if you're going to use the grid, it will maximize, it will use the 32 amps, which is enough for the I'll show you, which is enough for the 3 kilowatt, so it's a 3 kilowatt 48 amps. So we'll just leave it that way. You can let's see if it's get higher. No, we can't. So the maximum is 30 amps. Okay. So under voltage alarm. Now this is your battery. So my under voltage alarm, since this is a LiFo, I'll peg this one at 44. Means it will alarm when it reaches 44 volts. Oops. Under voltage protection, your end of discharge. So I'm going to peg this at 40. So based on my manual, it can go as high as low as 40, but let's just choose to have this as 41. Okay. Power save, meaning to say, if you want this, if the system is not detecting any loads, or the load is within threshold like 10%, 20%, this will go to a standby mode. But we don't do that. So just to check what are the options, let's choose. See, it's either enabled or disabled. But power save, we disable it, because that might have a problems if our load would just lights in the morning. So this will shut down. We don't want to do that. The date, so it's been set, okay, in 27. Okay, I think we're done, because this is already back from the menu on the first page. So it's lithium. Next, we go to advanced. Now, the advanced will determine what type of output you have. So 220, 30 in the Philippines. So we'll just choose that 230. That's okay. Next is rated frequency. Now, this is the reason why when you are trying to configure your hybrid off-grid to be on the battery first because of this settings. So we don't run on 50 hertz, but we are on 60 hertz. So that's it. And next, AC charger. Yes, it's enabled. So that if we don't have that much sunlight, if there are some storms or it's raining, your charger or your inverter will charge your battery. But we're going to limit its charging capability into specific percentage. So like this, it's 30%. I only want to have out of its 30 amps, I'm just going to have it 3 amps. So we'll peg at only 10%. I only want to use the grid in charging my battery at 10%. Well, I guess that's also the limit, the lowest value. Absorption. So this one is too low. I'm going to have this absorption into higher. I'm going to put it on 54.2. So the absorption is the second stage of the battery charging. The first stage is the bulk, second stage is the absorption. In most cases, like some very intelligent or branded solar charge controllers, they don't have absorption on your lithium. If you are setting it on lithium, there's no absorption value, but it's a bulk value. So next, float voltage. Now this one, even though this one is a BMS and this one also is a lithium, I don't want the Energier or the hybrid or the inverter to have a float. I'm going to disable this. So I'm just going to place the lowest value it can have so that it will not go into float stage. If you think you can do that in your setup, by all means do it, but lithiums, LiPos doesn't need float charge. You can do a research for it, but okay, 46, it's advisable not to float because they cannot accept any more current. Now on my case, I don't want to put a float value in it, so that's why it's the lowest value that it can get, so that it will not go to it. And next, you don't also need compensation on lithiums, so we're going to have it 0. So you have to treat this as you don't have a BMS. That's how I treat my lithium settings. So no compensation from the temperature. Next, auxiliary in. So I've mentioned earlier, you have multiple dry contacts, which you can, I would say, you can manipulate, or based on your design, you can do whatever it wants to do based on the corresponding choices. So I don't have one. So auxiliary 2. So just for the purposes of curiosity, let's check. So you can set it if it's battery low. If it's an overload, you can put in alarm, which is good. it's overloading, so it will light or it will do an alarm so that you will know. Temperature, if it's too hot, which is good, so at least it would give you now that you need to clean up. But if you have seen my previous video, I placed a filter on this. So if this one, I could place an alarm also in this, an audible alarm, so that I will know that, you know, the temperature is high. I might need to change my filter. Output short, which is also good. So there's an abnormality on the system. Overcharge. See, you can play a lot of things on the auxiliary pins. Inverter's fault. Fan running. AGS. The AGS, based on the manual, you need to configure it on the PC application. AC input connect, battery low. So anyway, let's just skip this. I won't touch this, but I'm going to have a different settings, I think, or other video just to highlight this, which is good. Auxiliary 2, we also don't do anything. And the overcharge protection. So let me say this HVD, high voltage disconnect. So we're going to well, this one is 56 volts. My battery accepts only 54.6. It's recommended HVD. So I'm going to send this to the distributor, and hopefully a firmware will be able to update and place the over voltage protection lower to 54.6 as suggested by the manufacturer. But since this is a performance, let's say a guide, so I'll be keep on watching on my inverter so that it will not go to a 56 voltage, high voltage of 56 volts. Okay. AC input voltage abnormal alarm enable, like earlier. Inverter to grid. Now this is good because this value, I'm going to change this value to 43. Oops. So this thing, what it does is, if your battery reaches 43 volts and you're using it as an inverter, this will bypass. So after the 43 volts, our end of discharge is 42. That will, the AOD will shut down the inverter. We don't want to do that. But what we want to do, if in the event that we want this to run as inverter side, there's no grid, and then when the grid kicks in and your voltage is 43 or 44, it will still do the power. Once it reaches 43 volts, it will do a bypass. It will bypass, and at the same time, so grid will now take care of your load, and it will charge your batteries. So very, very useful. This one, grid to inverter threshold, is an opposite to the earlier settings that we have, which is absorption, right? And this one, grid to inverter, it will only transfer back to the inverter using the inverter mode once. Oops. Well, let's go back. So grid to inverter threshold, bulk finished, we can change this. See, absorption finished. So this means that the inverter is fully charge, then we can have it back to the inverter side. So let's use this one. Next, okay, I think we're now into the first page of the setting. So let's go back and explore some of the functionalities of our hardware. So you have an error. So let's see what's the status. Status is no input. AC out, so it has an out 60 hertz, and since it's night, it doesn't have any MPPT charges. Battery is at 51.2. Work mode is under inverter mode. AC charger standby, so also standby. Okay, so let's see. I'm going to let's say information first. So it's your inverter settings and it's a firmware. Okay, now I'm going to turn on the AC input. Okay, now it stopped blinking because we already have the AC in. And let's check if there's an alarm. No alarm. Good. Status 60 hertz. AC output, MPPT charge, battery, inverter, standby. Now it's bypassed. Interesting. So the input, it detected it 273 AC, 60 hertz, no current since we did not turn on the AC out yet. So next video, I'm going to test drive this with a specific with the battery, and let's see how will this inverter works. So if you have any questions, just drop a comment, ask the questions, and thumbs up.